So this is the last section we're going to do for the whole year. We're going to do it in probably 2 days because it's kind of a bigger section. There's a lot of stuff in it. It's not in 14.6, so when you're doing the homework, just remember that it's 10.8. It's the same problems that are listed, but because this book... Can you stop with the car? Put it away. Like... Okay. Anyway, so it's like a tie between some stuff that we've talked about with some other stuff that we've talked about. We're just kind of going to bridge the gap now. So if we think back to a couple units ago when we studied complex numbers, we briefly discussed a way that we can graph on a complex plane what this complex number looked like. And we considered the x-axis kind of like the real axis, and then the y-axis we thought of as the imaginary axis. And what we would do is just graph both components. So if we wanted to graph a plus bi, we would just go in the real direction a units. We'd go up or down b units in the imaginary direction. And this point would be called a plus bi. Now, if we connect from the origin to this point, and we call that R, and we label the angle with respect to x, or the real axis theta, we have a right triangle that we could use. And now the question is, how could I find this distance here?
A squared.
Yeah.
A squared plus b squared
Would equal r squared. So r would be the square root of a squared plus b squared. Now, what would a be?
A?
Mm-hmm. So how would I find this distance?
Square root of b squared.
Well, let's think SOHCAHTOA.
Okay. A? You say A.
Yep.
Sine or cosine?
Well, which one? That's the question.
Let's make
If I have r
What?
and I have a, what function would I use?
Opposite?
R cosine.
So a would be r cosine theta.
Yeah, that's what it's
And if you don't see that, right, cosine theta would be adjacent over hypotenuse. Does that make sense? Does this look familiar yet?
So, okay.
What would b be? R sine theta. We still have the convention that tangent theta would be opposite over adjacent, so b over a. These equations should look exactly like the polar equations we studied in chapter 9, 10, except it was x equals r cosine theta, y equals r sine theta. Sound familiar? Okay, good. Now, here's how we're going to tie all this stuff together. If z equals a plus bi. Okay, so now we're tying all this stuff to complex numbers. Instead of a, how else could I write that? R cosine theta plus, what's b? R sine theta times I. And just so you guys get used to the format, if I factor out an r, what would be left? Cosine theta plus sine theta times I. Usually what we'll do is write the I first. So I sine theta.
Oh, it's a CIS.
This is CIS.
Doesn't matter actually.
This is what we call, yes. Well, it doesn't, but it's just easier to write I sine theta. This is what we call CIS form. And it's very easy to remember because the C stands for cosine, the I stands for I, and the S stands for sine.
Is there a word for it, or you just say CIS?
CIS. Yep. Okay, so this is a polar / imaginary version of this complex number here. So this is complex or rectangular form. And instead of polar, we're calling this CIS form because we're explicitly using cosine, the imaginary unit, and sine. Okay. Sometimes you'll see this called trig form.
What is that Z looking thing?
A Z.
Okay.
The Z-looking thing would be a Z.
Well, I didn't know. 'Cause Z's don't-
Oh, what's that plus?
I'm pretty sure I said if we let Z equal.
What's that
Okay.
plus looking thing?
All right, so here's what we need to know. Complex numbers, which include real, just imaginary, or a combination of both, like A plus BI. Okay?
What's that say?
Real, just imaginary, or A plus BI
Wait, is there a comma?
have a trig form or a CIS form. Okay, so any number that we can think of, whether it's real, imaginary, or it's like A plus BI, will always have a CIS form.
So, just
Okay.
imaginary or A plus BI, or is it 3 choices?
Well, a complex number, by default,
It's either real.
is either real or just imaginary, or it's got both terms, in which case it's still imaginary, but you'd have a real number in there as well. Okay? Let's look at some examples. So let's take Z equal to, that's a Z, Kev, yeah. Let's take Z equals 3 CIS pi over 3 and put into rectangular form. Okay, so the book may use this notation or not, but you need to know what this stands for. So if you don't, the first thing you should do is write it out in the long format. What does CIS stand for again?
R sine.
It stands for cosine theta plus I sine theta, right? What is the theta in here? Pi over 3. So let's write it out as 3 times the quantity. Cosine of pi over 3 plus I times sine of pi over 3. Oh, look, now we have to remember trig. Yay.
60 degrees.
60 degrees. What's the x coordinate, right? Cosine's x? What's the x coordinate for 60 degrees?
2 or 2.
It's a half. Very good.
I mean, half. Sorry, I was sneezing, that's why.
That's what you said.
What would the y coordinate then be, Kevin? Very good.
I remember that.
I hope so.
I don't.
I'm going to fail this unit.
So if we just distribute this out, we get 3 halves plus 3 root 3 over 2 times I, and there is the rectangular equivalent of this weird CIS number.
So that's the answer.
Yeah, that's it. Pretty easy, right?
No, you're just saying that now. It's just going to get really hard.
No, so far no.
So far.
He said, so far.
Okay?
We already have 20 more minutes of class, so.
Don't worry, guys. It'll be fine.
Say,
Another example. Let's go the other way. Find the trig or CIS form. Just be comfortable with both terms. For the number negative 2 root 3 plus 2i. Okay?
That's like A plus B.
Yeah, so this is exactly a plus bi. To put things in CIS form, we need to know, so let's take a look. We need to know r, and we just need to know theta, right? That's it. So let's find r and theta, and we're done.
R equals
R is the square root of what?
A squared plus B squared.
So let's plug it in.
R is negative 2,
So what is this going to be? 4 times 3, 12 plus 4, 16. Square root of 16 is?
Wait,
What I told you, not even doing that problem. I said,
Hey, you're finished. You're doing the quiz?
Yeah.
So, plus that.
I mean,
I work at a
where do you see it?
I'll go in the back, but that's where they drop it. And I'll be like, so.
They call you stupid.
Where's your profit? Where'd you get an ACT?
You probably did. I didn't say you were stupid.
Yes, you did. Oh, you did.
I didn't say it.
No, say you said it. I said because you're small.
I said he called you stupid.
No, I said because you're
Don't
small.
compare. That's what definitely
Ooh, you gonna take that, Garfield?
Hey, what'd you
Show
get?
him your badge.
You got 21.
Yes.
What'd you get?
I took 3.
I took 25, 28.
But my Harvard.
What'd you get?
What'd you
ACT.
get?
26. Alexis.
More.
What'd you get?
What'd you get?
Come on, we're all saying it.
Yo, Jack, what you got?
Busy.
You got 36.
He got busy.
You got like a 30 something.
Actually, I got 25.
Okay, Michael, what'd you get? What'd you get?
I got the left.
Alexis,
Yep.
ACT.
I went to the
Holy
school
crap.
Alexis, come on. It's
And they had like a conveyor belt at
Alexis,
like
what'd you
at
get?
the airports where they check your bag.
Did you get above
cool.
28?
What school was that?
Kenwood Academy.
Nice.
Alexis.
So you could walk on the belt and get places
I
faster.
guess I got the highest score.
No.
Oh, you're talking about
Like,
you have to
check
put your stuff.
bag
Oh,
and
never
then
mind.
walk through the metal detector.
When you said airport, I was thinking about, you know what I'm talking about? Where they have the
Yes.
belt and you
That's
can walk.
only that's scary. Where was that?
Okay. Sorry about that.
It was like by UIC. Not UIC, UFC.
So where were we? We found R. We need to find theta.
In order to
UFC.
Easiest way to do that, guys, is to use the equation tangent theta is what? B over A. So let's just plug everything in. Tangent theta, what's B?
-2. I mean 2R.
2, just 2.
Oh, just 2.
Why are you doing tangent?
Because it's the easiest way to do
But
it.
it doesn't matter which one.
You could do the cosine one or the sine one.
Yeah.
And then A is
-2.
-2√3. If we simplify,
And you're gonna have to do a boot.
It's gonna be.
-√3 over 3 to put it in the normal trig values that we're used to seeing.
How you got that?
Reduce the 2's and then multiply by √3.
And then boot.
That's awesome.
So do you not know how this works? Yeah, that.
Okay?
Okay.
Got it? All right. So then now we have to figure out, okay, here's how we check which angle to pick. What quadrant, if we go back to the original number,
Second.
this is second quadrant?
Yeah.
Okay? So what angle, Kevin?
So it's
The angle
third
is.
quadrant.
Is it really the second one?
Because A is negative, so we're going to go left, and then B is positive, so we're going to go up. So what is it?
The angle?
Yeah.
Well, let's see. How much left to know that exactly is 125?
I don't think 125 was an angle we ever studied.
And also it's 90, 120, 135.
Okay, 135 I could see, but that's not the tangent value for
I know.
135.
I'm just saying the numbers and then it's
Okay.
160.
160.
132.
132.
Guys, don't embarrass yourselves on YouTube. Come on.
What are we talking about?
Wait, so what formula do we use?
It's not a formula. Just think about the unit circle and think about what angle would have this tangent value.
None.
Oh!
I'd rather do sine
Oh,
because that's
I
easier to
see.
find.
What was it? It was 90, 120. Or-
135, 150.
Let's make it 120.
It's actually
I got negative 30. But
B over A. It's 2 over.
It should be the equivalent of 150 degrees.
Oh, that's what I
It's
said.
square 2 over 3 over 1 over 3. Which is no way it's the opposite. It's
Okay, now
therefore-
it's fast.
So you could either write it as 5 pi over 6 or 150, however you want to write it. I'll do.
we need some
Radius.
touch-ups, you know.
Good thing we're doing this before the final. Yeesh.
Yeah.
Okay, so theta is 5 pi over 6. Radius is 4. So our CIS form would then be,
Cosine,
Four.
times cosine 5 pi over 6.
you can write it either the long way or the short
CIS.
way.
Oh, yeah.
Oops.
Either way is fine.
Oh.
CIS 5 over 6.
CIS is.
That's on CIS.
That's also from Star Wars. The CIS.
What?
The droids. Can't see
Multiplying and dividing numbers in CIS form. Okay, so here's the point, or one of the several points why we're doing CIS form. When numbers are converted to CIS form, there's some nice easy rules that you can use to multiply and divide, which save a lot of time. So let's start with multiplying. Let's let Z equal R CIS alpha, and let's let W equal another complex number we'll call capital R CIS beta.
RCIS alpha. Wait, what is that? Is that beta? Beta.
What did sign look like?
No.
So now, if we multiply Z times W,
He's the one who said it.
Don't say.
we're going to get, if I just kind of rearrange some things, R times capital R, and I'm going to write things out in long form. So cosine alpha plus I sine alpha, and then cosine beta plus I sine beta.
Only this problem.
I sin. I have a problem.
Okay. What we're doing is deriving or proving why that little trick that we're going to do is going to be actually valid. Okay, so it's going to look longer than it's going to be, but so let's just multiply some stuff out. If I distribute or FOIL this out, whatever you want to call it, what do I get?
Cosine squared plus
It's not cosine squared because they're two different angles.
cosine A cosine B plus cosine I cosine sine A B
So slow down, cosine
A
sine
B
beta, yep.
plus I sine
I'll just
A
continue on the second line,
cosine
plus
B
I
sine A cosine B plus
Slow
I
down.
squared sine A sine B I squared equals 1.
Okay, hold on. Everybody good with multiplying it out?
No.
No, I'm still working on that.
Still trying to write this down.
Well, maybe if we focused.
I did.
You see
I'm,
that?
I'm on the I
I
squared.
just finished this in 2 seconds and you still haven't covered it.
I love how when Saeed actually pays attention, he just rubs it in everybody's face. Then he gets what's going on.
And then you get
And
some
there's
stuff.
the other times.
And then there's the other guy. Yeah.
Mr. G, I'm still up for giving
What
Saeed
was
a haircut.
2x plus.
Or you could-
It's like 60.
Okay, so let's clean some things up. Here's what I'm going to do. This I squared is -1, yeah?
Mm-hmm.
What I'm going to do is put the real stuff together and kind of put the imaginary stuff together. So I'm going to rewrite. I'm going to keep cosine alpha and cosine beta where they are, since those are real. And then my other real term is actually this last one, because I squared becomes -1. So that's really just going to be minus sine alpha sine beta. Okay, and now what I'll do is group the imaginary terms together. So that's this one here and this one here. I'm going to factor out an I. So then it's going to become I times cosine alpha sine beta
Plus sine.
plus, let's write it as, let's put the cosine first. Cosine beta, actually it doesn't matter. In fact, you might even be more used to seeing it the way we have it. So let's do sine alpha cosine beta.
It's easier to see angles.
Mm-hmm. So now, another review from a different chapter. This formula right here is from the first unit we did this semester.
I'm on it.
Anybody remember?
Wasn't the first one when it was like 2
What is it?
y?
It's check that.
Which one is cosine, cosine minus sine, sine?
Oh, we
Sine,
still
sine,
can use
cosine.
that formulas, right?
Alpha plus beta.
Very good.
Ooh, I think it works.
That's one of the addition formulas.
Can I get that sheet?
Plus, guess what? Right next to the I, we have another formula from chapter 9.
Uh-huh.
So we have I times, which one is the one that's cosine sine plus sine alpha cosine beta?
So you get a cheat sheet. Hold on a second. That, is it sine alpha plus beta?
Absolutely.
It's just it was inverted.
Mm-hmm. So let's see what just happened here. What's the conclusion? Because now we're going to be able to do things real quick. If I multiplied z times w, keep in mind z and w was this weird trig number, this other weird CIS or trig number. We multiplied them together. What really happened? The two radiuses get multiplied, right? And then what happens with the trig part? What do we do? Because this is CIS, isn't it?
Yeah, it is.
Cosine, I sine. So it's still CIS form. It's just the angles now.
CIS.
We just added, right? And if we wanted to clean things up even shorter, this is the same as R capital R times CIS alpha plus beta. So in other words, when you're multiplying numbers in CIS form, all you need to remember, you multiply the radii and you add the angles. Okay? So, for example, let's say I have z equals 5 times cosine of pi over 2 plus I times sine pi over 2. Let's say w is 2 times cosine of pi over 4 plus I times sine pi over 4. I'm guessing not here, but I could be wrong. Not here. Okay. And let's say I wanted to find z times w.
Mr. G, do we have to show all that work?
No, that was the whole point. I proved to you. Together we figured out all we have to do is this. We don't have to do all that.
Wait, really?
What?
That was the whole point of that, you guys. What's the shortcut? Instead of doing all that,
Oh, wait, so
the final answer, all we have to do is multiply the radii and add the angles.
So
That's
it's
it.
10.
10
CIS.
CIS
pi over 2 plus pi over 4.
pi over 2 plus pi over 4.
Which reduces, actually. Is
So let's figure that out.
It's gonna be
Well, we gotta do cosine.
90 plus, what is it?
No, not even that.
Pi over 2 is the same as
45.
2 pi over 4. So if I add those together, it's CIS 3 pi over 4. So now, depending on what kind of answers we want, if we want the number in complex form or in the trig form,
Wait,
this is good.
2 pi over 4.
And if we don't want the numbers in trig form, we could just now from here write it out and figure it out. This would be the same as 10 times what?
10 times the
Cosine of
3 pi over 4
plus I
plus I sine.
sine 3 pi over 4. And then we can just plug in unit circle values. That's not hard. These are the easy ones, guys. What are the x's and y's for 45 or pi over 4?
0 pi over 4.
What?
Wait, 3 pi over 4
The
is
first
1
one is
Just 45 degrees, guys. What's
Root
x
two
and
over
y?
negative 1 over 2.
Root 2 over 2, root 2 over 2. But 3 pi over 4 is in what quadrant?
negative 2.
Oh,
So negative root 2 over 2.
No, wait, no.
Yes,
Root
yes.
two.
You're right.
Add
Plus
to
I times, what's the sign of 3 pi over 4?
2. Square root of 2.
Positive root 2 over 2.
Yeah.
That's my favorite one.
So then it's negative 10 degrees.
So if we multiply it, negative 5 root 2 plus 5 root 2i.
Let's make it down by
Look at this guy.
Okay, if you're really rusty on the unit circle, I really suggest that you start reviewing that
Ask me-
now.
You're asking me a question about the unit circle.
What are the coordinates for 30 degrees?
Coordinates. For 30, oh, okay. That's half.
Nope.
Let me ask you.
I bet Diana knows. Diana, what are the coordinates for 30 degrees?
I know.
It's
Is it pi over, no, square root of 3 over 2 and 1 half?
There you go.
My bad.
Square root of
Okay.
3 over 2, 1 half.
Let me ask you another one. What's the coordinates for 127?
Coordinates for
I can
127.
write it.
Wait.
127 comma 0. Are you still recording?
Yes.
Oh, my bad.
Dividing.
Follow me on Instagram.
Okay, so do you guys kind of see how multiplying works? Pretty easy, right? Let's see if you guys can guess what the rule is going to be. If I wanted to take z divided by w, keeping in mind again that z was little r, CIS alpha, and w was big R, CIS beta. See if you can make the connection here. When we multiplied, what did I do with the radii?
Oh, it's gonna be R over R and
When we multiplied, what did I do with the radii?
Multiply.
We multiplied. When we divide,
Divide.
we're going to divide it. So
yeah, that was happening.
we're going to have r over big R, because we're doing z over w. And now, what did we do with the angles? When we multiplied, we
Cancel them.
Add them.
added them. So when we're dividing, what do you think we're going to do?
Subtract.
Easy.
So we didn't have to actually solve it.
Okay, so yeah, we're not going to go ahead and derive it, but if we wanted to derive it, it'd be pretty similar.
That's
Okay.
it.
Well, we're going to do an example now.
No.
He said,
Let me show you another example. What's it that one? No, really, no. I'll show you.
Let's go ahead and do the one we just did, but divide z. So let's do the same
Oh
thing.
my lord.
Z equals 5 CIS pi over 2. W equals 5 CIS, or I'm not, sorry. It was 2 CIS pi over 4. So if I wanted to do Z over W, what would the answer be?
5 or 2.
5 over 2 times CIS of
Pi over 2 minus pi
Is that
pi over 2 minus pi over 4. Good. And if we clean it up, that's just pi over 4? I believe that. So this would be the answer in trig form if we wanted it in that form. If we wanted it in rectangular, we go ahead and just multiply it up. So 5 over 2 times cosine of, whoops, pi over 4 plus I times sine of pi over 4. I know I'm going kind of quick now, but you guys okay?
Yeah.
What's cosine pi over 4?
2 over 2.
See, it's coming back. What's sine of pi over 4?
Root 2 over 2.
Good. So then if we clean this up as much as we can, we get 5 root 2 over 4 plus 5 root 2 over 4 times I. So this is the answer in rectangular form. This is the answer in trig form. Okay? Now, we're going to try to figure out this last rule.
No,
Hey.
we're good.
No, because it's easy, guys. It's easy. It's easy.
I want to show you. I'm showing the problem.
If z equals RCIS theta, I'm going to ask you guys to think, because you guys can figure this out. What is z squared going to be?
R
It
squared.
would be RCIS.
R squared CIS squared.
We're on the right track.
No, it's gonna be R squared. What was the formula?
2 R.
It's gonna be R squared
2 CIS.
A plus B squared.
Slow down.
Nice try.
What do we do when we if I'm multiplying z with z? So RCIS theta times RCIS theta. What do we do with the radii?
Squared.
We multiplied them, so that's where the r squared comes from, right?
Oh, 2 CIS.
And what did we do with the two angles in the formula when we multiplied?
Add 'em.
We added them. So what's theta plus theta?
2 theta.
There you go.
CIS 2 theta. That's it.
It's not hard.
That's the answer?
And
What
then
do you think
we're gonna have that cosine 2 theta thing.
if I did z to the n,
Oh, jeez.
so any power?
R
R to the N,
and
CIS, and theta.
You guys nailed it.
Yeah, let me show you the problem.
This is Demoivre's theorem.
Demoivre, you are a G.
Let me write that down.
You still gotta.
Let me write that down. Then I'll show you.
Okay? And now we have an even faster way to expand certain kinds of binomials. So for example,
Give me an example.
let's say we have negative 2 root 3
What's that?
plus 2i
What that thing is?
to the 8th.
So you're gonna get.
So let's just recap what we've done this unit.
Let's make it negative 2 to the 8.
Hold on. I just want to tie everything together here. I know you guys see what to do, but one option would be to FOIL this out and do it the long way, right? Another option would be to use somebody's triangle,
Or we
Pascal's.
can use that.
where you do and you figure out all the coefficients. You could do binomial theorem, or
Or we can live
Demoivre's theorem would help us here. First, what I would do, Demoivre's theorem helps us if the numbers are in trig form, in CIS form, right? This is not in CIS form. So let's put it in CIS form. So in CIS form, what do we need? We need a radius, and we need an angle. So let's find those. Radius would be the square root of a squared plus b squared. So negative 2 root 3 squared plus 2 squared. That's going to be 16. So the square root of 16 is 4. Okay. And if we do theta, again, we can do tangent theta equals b over a. So that would be 2 over negative 2 root 3, which is the same as negative root 3 over 3. It's the same number as before, we're just doing it to the 8th power. So to save time, what was it? It was
150.
so 5 pi over 6. Okay, so the hard part is done. We figured out what the radius is, we figured out the angle. So let's write it out. In CIS form, this number is going to be 4 CIS 5 pi over 6. So currently z is 4 times CIS 5 pi over 6. Okay?
The way to times everything by.
So what is z to the 8th going to be?
Equals 4 to the 8th power.
4 to the 8th.
CIS 8.
CIS
8.
8 times 5 pi over 6. So let's clean it up. And someone help me out. What's 4 to the 8th? This is 40 pi over 6, so that's 20 pi over 3. I can do that.
It's a big number.
65,536.
65,536. All right, so we're almost there. This let's see, what quadrant is this going to be in? 20 pi over 3 is really close to 21 pi over 3, which is 7 pi. So it's almost back here on the x-axis, on the negative side. So we're in second quadrant. Don't pay attention to the 20. It's really the 60 that we're worried about, right? What are the coordinates for 60 degrees, but in quadrant 2?
1/2.
Negative 1/2. Root 3 over 2. So then when I write this out, it'll be 65, 5, 3, 6. I'll just go ahead and show all the steps. Cosine of 20 pi over 3 plus I sine of 20 pi over 3. And now we'll plug in the trig values. So negative 1/2 plus I times root 3 over 2. And if we simplify it, we just take half of that number, so that'll be negative 32768. And this will be the same just with the root 3 attached. So plus 32768 times root 3 times I. So if we wanted to... I am. I'm just trying to...
Are we done?
With this, yeah.
Nice.
So this problem, which would have taken a lot longer, we converted it to CIS form, used the Demoivre's theorem, and here's our answer. Okay? So instead of foiling or the triangle or binomial theorem, there we are.
Move one stick that way so it makes a square.
All right.
Move one stick.